baby, won't you sail with me out on the rolling sea? We'll find some place to go, maybe down to Barbados. It's an island off somewhere in the middle of nowhere, sailing to freedom, you and me.
We're trying to work out the best thing for the fit out, the lightest thing. Now I've looked at Delos's stuff, and Delos is very thorough and he goes through it beautifully. What I probably didn't like about it was I think it's going to be too heavy. His boat's more of an expedition boat, and mine's, I've got to try and make it lighter. It's like a black core flute, but the core flute's not longitudinal. The core is transverse. And when he was doing the corner, he was pouring the mixed epoxy in it, and he used quite a bit of epoxy just to make one corner. And if I did all these corners like that, I think his boat will sink. My boat will sink. His boat's a lot bigger. Originally, we were thinking of doing this. So this is a honeycomb aluminium. It's super light. I'm not entirely sure how good it is to work with. You know, it's not. I don't think it's going to be as easy to work with as wood. You know, getting corners and edges because it's aluminium, and also basically, what have we got? Lots of voids. So I'm not sure about that. Now I did look in the bundle of goodies here, and we've got pieces where we can join these sheets. So it can be quite neat. But I still think we will have a better weight saving with foam and fiberglass, and I think it's easier to work with. I've used this board before. This stuff is absolutely great. It's super expensive, but it's super strong. It's impregnated with carbon fiber. I don't know if you can see it. Maybe if I just, you get it glittering. It's good when you put bolts through it because it's incompressible. Super expensive though, so let's just show it to you and be done with it, because it's not going to happen. Check out this, 22mm thick, so it's got probably a 2mm thick layer of glass on the top and probably maybe a 1.5 on the bottom. Super light, super strong. Now this is ordinary shiny sheet. This is about 2mm, 2.5mm. Oh no, it says thickness 2.3mm. This section here is 798 grams and it's 500 by 500 millimeters. So this is 1/4 meter. So if we times that 4 times that, so it's 3.2 kilograms per meter squared. That's actually quite heavy. I think you can actually go down a layer of glass on this. It doesn't have to be 798. Get it around 600, be a bit better. But basically you spray the foam and you simply against the foam. Now we come to the foam insulation. Is it going to be cut foam or spray foam? Delos showed a product called Neolon, which comes in sheets you can cut and place. I'm in two minds. I can understand how with foam you physically actually spray the foam to the aluminium, so you don't actually get much air going to the aluminium. And when you don't get air, you don't get the humid air touching the aluminium and then actually condensing down the walls and going into the bilge. So if you spray the foam on, you're less likely to get much condensation on the walls. Now with the Neolon, I think I've got issues with it. Look, I think it's a great thing because you can really cut it to match, and you can get one side sticky back. But no matter how good you are with it, you're still going to get some voids. If you've got some voids, you're going to get air, and air's going to be humid, and you're going to get condensation on the aluminium, and so you're going to get water coming down into the bilge. Now that's one thing, but you're going to get moisture behind your wall panels, so that's going to be mold, God knows what. It's going to, you know, you get that smell after a while. So I think ultimately the best thing is to spray it, even though it's very, very messy. Whoa, baby, messy indeed. Especially since the variability in humidity and temperature will affect the amount the foam will expand to, leading to the possibility of a lot of remedial work to cut the foam back to the frames and stringers. This guy did a pretty good job. The layer of foam looks constant, but if you don't get it right because it expands, then you have days and possibly weeks of cutting or grinding it back. Maybe someone knows this. I was thinking of having a big board with 2 handles on it and quickly spray the foam and then lean that on. I mean, it's a bit of ridiculous because I think the foam has got quite a bit of strength to it, or pressure to it as it expands out, and so it'll probably push me out. But it'd be good to get some kind of boundary. Can you clamp the boards down and then have, for example, holes where you spray through the frames and then it just actually fills the void? So you actually clamp that board down? I don't know, maybe that's a good idea. And now it's over to Bart at Tech Corner.
Hey Sailing into Freedom fans, welcome back. And remember when I showed you a few weeks ago the nav desk throttle quadrant? Well, today we're gonna do the helm throttles, which are actually fairly difficult, and I'm quite chuffed about it because it's a design I made from scratch. So it's a little bit complicated and we don't have that much time, so let's dive right into it. Okay, so as you see here, we actually have a helm that can move in 2 positions. It can go to the downside position and also to the top. So it's not really easy if you put your throttle body on the downwards position and you want to steer when you're anchoring. That doesn't work. So we needed to come up with a small throttle that could be put on the helm pedestal itself. So it's not really that difficult because it's digital, it's just an electric connection, it's not dealing with wires and so on. So we started doing that by first looking for the electronic parts, and then we created the first sketch, of course, like I've shown so many times in the past. So this is actually a potentiometer. A potentiometer, for the people that don't know, that is an electronic component, like I will show you here, which is used to regulate current and power in electronic setups. It's a tiny part and it's the basis of every joystick or electronic throttle. So I'm actually mocking that out here. I'm adding some sketches. I'm adding the 2 indents, how it's screwed on to the side, trying to make the little pins that are sticking out in the back. And I keep going. I have to be careful not to push the wrong button here. And I already started on my 4th sketch, which is for the base plate where it will attach to. And so you basically screw it. So I put some screw thread on there. You basically screw the potentiometer to that plate. That's how we start. Now the next part is actually, I'm importing some parts here from McMaster, is a ball bearing, which will actually, because that axle will rotate, so we'll actually connect to the next part over, which I'm designing here now. It's a simple circle with 4 holes in it. And again, we extrude that, we put some standoffs there, we put some holes and screw thread in it so we can attach both plates to each other. Now we keep going and I create another sketch at the back, which is actually gonna be the main body of the throttle component. So I extrude that and you already see a little bit, it's gonna be a round throttle, so you already see the shape taking place. Now I imported this little piece, which is actually a ball indent, so it's a little tiny ball that can be pushed back, and the reason for that will become clear is that actually I need to have a way to center the throttle so that you feel when the throttle is in the center. So I'm building a little block here so I can make a little hole in it, So I can actually move that part into there and screw it in, and that will be used with a little indent that you will see in a minute to actually determine the center of the throttle position. Okay, let's keep going. Let's get rid of these two sketches. In the meantime, I'm also in the back. I'm putting the standoffs in there. I'm creating a plane, which we don't really need at this time. And you see me here putting some holes into that plate just to make it lighter. And yeah, that was the only intention. Now this will be the part that will be mounted to the axle of the potentiometer, so it will turn around. And I'm doing that so I can create an outer shell of this throttle body that you can turn around. Now I'm making some more sketches in a minute. Sorry if this doesn't come over very smooth, but it was a real difficult design. So I'm creating two more planes here, just so that we have the center here and that I can put holes. These will be for the grub screws that will screw this part onto the axle. Let me make some holes for that, and one on this side. So this will actually screw two grub screws in, so you can attach this round part to the potentiometer axle. Let me get rid of the planes again. And we continue. I make a new sketch again, which is two little circles, and that's to make the indent. So I just cut it out, and we continue on. I actually cut off the axle because it doesn't need to be that big, and we still continue. So these are the grub screws I just mentioned. And at the moment, let me orientate where I am. So now I'm actually starting to design the outer body, that the part that will turn around. And I just did that by extending this little circle. I'm actually joining these two parts together, and then I'm pulling the throttle back over the other one. So this outer part will turn over the inner one, and the inner one will be fixed to the helm. I'm also building a little handle for it, because it also will show you what the center point is. So this is just cutting it off and filleting it a little bit to make it nice and smooth. Then we go making two holes, and these are actually necessary to be able to screw the grub screws, because otherwise you can't go in there with your hex tool and screw them fast. So I extended this hole, and then I made two holes in the outer shell. These will be capped off later with a little plug. I'm actually changing the material here. I'm enlarging the holes a little bit, because otherwise it's really difficult to see where you're putting your hex tool. And we're kind of reaching almost the final stage. So I have an outer turning body that is actually operating the potentiometer. Now I still need to make a back plate, so I'm putting some standoffs in here as well, which will be used to screw from the inside to the back plate. I'll show you later because I printed this off, so you will see it live. I make the back plate, and then we still need some holes to put the cables through, and also to mount the back plate to the helm itself. I put a grommet in there so we don't shave the cable, and we kind of have almost the final design. So let me run through it quickly. And I also wanted to put some branding on it for the Elcano challenge. So here you see the final throttle And now let's have a look on what it looks when it's printed. So it's a prototype. We'll actually probably will be making this in aluminium later, but initially we'll start with 2 prototypes which will be 3D printed so we can test them, and that's already been done and Plucky has them. So you just seen them being printed. I just print them again so I can show you physically what they look like. The real parts, this is PLA, but the real parts are printed with polythalamide with carbon fiber, which is a real expensive filament, and they are already in Vietnam, so it's a very strong filament and should be able to withstand sea spray and water and so on. So this is just to show you. We have the outer shell, we have the back plate, the little inner plate, and we also have the main body. We need to get rid of these supports, so I'll do that now because in order to be able to print this, it needed to put supports on there. So let me just break that off and I'll be back in a minute. Okay, so here we have our 4 parts without the support. So what's gonna happen is actually the potentiometer will be placed from the back in here with the axle sticking out. And then you have this part that with the 4 holes will be screwed on the main body with the axle of the potentiometer coming out here. And then inside here you see this little indent that's actually to stop it from turning 360 degrees. So it will actually hit this little block here, and inside here you will have the indent, the little ball indent, and that will actually attach. I don't know if you can see it, but there's a little indent here, so you actually will feel when you're turning over the center point. So, and in the back you have 2 screws coming out for the back plate. The back plate you fit onto the helm, and then you first screw this part, so you put the potentiometer in here, and then you sorry about that, and then you screw this part with those 2 holes into the back plate. This part has been done already, and then you simply slide over the throttle, and you actually will be able to steer forward by moving it this way and steer backwards by moving it that way. And then, as I said, the 2 grub screws holes are here, and then you have these little plugs that you just simply push in and it's tight. And what I didn't mention before is also we made a little groove here. This will have a plastic seal so that we can keep the moisture out, and it will actually seal off this entire compartment so that not that much water and spray can go into it. So this is our new throttle, and now over to Plucky, I would say, to show you the real final result.
And this is the final product, even with an Elcano label on it. Good on you, Bart. So we've got this, we've got a whole bunch of spares. I mean, we need 2 of these. We've got a second one here that hasn't been put together. And we've got a bunch of spares. Actually, we've got a heap of spares. And if you look in the background, we're going to be doing some episodes coming up about the Peplink year. And this is our way of keeping in touch with you guys. when we are sailing. Currently, it's being looked at by Bart through the Wi-Fi here at the office, and Bart's configuring it and setting it up. We're also getting the PepLink engineers there overseeing it and having a look at it too. So, so far that's all good. We had a little problem. We've got a Vietnamese SIM card here, and Bart's been accessing it through a German VPN, and it was all working, and then suddenly it didn't work. Don't know why. Who knows, people? But anyway, it's all good. Lots of stuff going behind the scenes, and hopefully we'll show you that soon. I bid you good night. I hope you're doing well.